Good evening to one and all present here. In this video lecture series of manufacturing technology subject, we are going to discuss about tool life and its important and some of the important definitions of the manufacturing technology. In this previous lecture series, we had already discussed about single point cutting tool nomenclature, cutting fluids, cutting tool materials which is used during the machining process, and what are all the different types of each aspects during the machining process, and also we had discussed about the tool wear, etc. Tool life. What is tool life? The tool life is the time interval for which tool works satisfactorily between two successive grindings or re-sharpening of tool. It is expressed in following ways, such as time period in minutes between two successive grinding of tool, and also number of components machined between two successive grinding, and also volume of metal removed between the two successive grinding. Time period, number of components, and then the volume of the metal. It is expressed as volume of metal removed per minute, Vm, equal to pi dt Fn mm cube per minute. That means d is the diameter of the workpiece which is machined, t is the depth of cut which is given during machining process, f is the feed which is given during the machining process, and n is the number of revolutions of job per minute. If t is the time for tool failure in minutes, then total volume of metal removed up to tool failure is determined as Vm, which is equal to pi into d into t into f into n into t, capital T. That means time. It is expressed as unit is meter per minute. Cutting speed can be determined by the formula pi dn divided by 1000 meter per minute. Pi dn, which is called to 1000 volume. The tool life is calculated TL, which is called to 1000 VFT, capital T, small t, mm cube. Next, we will discuss about what are the various factors affecting the tool life. Some of the factors are cutting conditions or which is affecting the tool life is cutting speed, feed and depth of cut, tool geometry, tool material, which type of tool material which is used during the machining process, and also the type of workpiece material which is machined during the machining process, and the nature of cutting, whether we are using the oblique cutting or whether we are using the orthogonal type of cutting, and the rigidity of machine tool and work, and also what type of cutting fluids. Cutting fluids also influences the tool life. Next, we will discuss about the Taylor's tool life equation. Taylor's tool life equation determines that Vt the whole power n, which is equal to C. V means cutting speed in meter per minute, and T is the tool life in minute, and C is the constant, n is the index which is depends upon the tool and the work. Next, we will discuss about the different important definitions for in case of manufacturing technology. What is the cutting speed? It is the speed at which the workpiece moves or rotates with respect to the tool. The other definition of cutting speed in lathe means the number of meters measured on circumference of rotating job that passes cutting edge of tool in 1 minute. The formula of cutting speed is V, which is equal to pi dn divided by 1000 meter per minute. D is the diameter, n is the number of revolution. Next is the depth of cut. It is the distance that tool bit moves into work. It is usually measured in inches or millimeter. Volume of workpiece material removed per unit time. Next one is the depth of cut. It is the advancement of tool in job in the direction which is perpendicular to surface which is being machined. The depth of cut is defined as a formula capital D1 minus D2 divided by 2. D1 is the diameter of job before the machining process. D2 is the diameter of machined surface or diameter of the job after the machining process. Next important definition is defined feed rate. It is the distance that tool travels one revolution of the part. It is also defined as the amount of advancement of tool per revolution of job. It is usually given in millimeters per revolution of job. Feed, which is equal to L divided by Nt. L means length of the cut which is formed during the machining process. N is the revolution per minute of the job during the machining process, and T is the machining time. The cutting speed and feed determines the surface finish power requirements, and material removal rate. Next one is the metal cutting. It is a type of process in which a piece of raw material is cut into desired final shape and size by the controlled material removal process. It is a type in which removal of material from workpiece is affected by relative motion between cutting tool and workpiece. Final one is the MRR, that means material removal rate. Volume of material removed per unit time. It is mainly function of speed, feed, and depth of cut, etc. Thank you.